Hello everyone, I'm Owen, and today I'm going to explain to you the first question of IMO in 2025. A straight line on the coordinate plane is called sunlight. If it is equal to 0 on the x-axis, the y-axis and the line x plus y are not parallel. Given that the integer n is greater than or equal to 3, finding all non-negative integers k makes there are two different n lines on two planes. The following two conditions are met. The first is for all positive numbers a b that satisfy a plus b less than or equal to n plus 1, and at least one of these n lines passes through the point a b, and the second, and the lower k bar in this n line is sunny. Let's first interpret the title, which gives two definitions, called the sword of sunshine. So let's take a look at what is between non-sunlight. Non-sunny straight lines are naturally those parallel x headquarters and parallel y-axis. Parallel x plus y equal to 0 is the one whose slope is equal to -1. With these three types of straight lines, we call them non-sunny straight lines and sunny straight lines. Naturally. What about its slope? It is not equal to 0, nor is it equal to infinity. It is not equal to -1. Then, let's draw all the points A, B in this diagram. First, construct a planar Cartesian coordinate system. What about when A plus B here? When it is equal to 2, we have the point B1, when A plus B equals 3, we have 2 points 1 and 1, 2. And we also have 1 and 1 until A plus B equals n plus 1, and we also have 1 and 1, and continue like this until n1. These points, then, at this time, we return to the topic, in which we can divide the k into several categories for discussion. First of all, the first case is that when k is equal to 0, k is equal to 0, then we are a sunny line without using all non-sunny lines. We can use all the numerical x and x equals 1, x equal to 21, until x equals n. This n article. A vertical straight line, obviously, can cover all direct points to it. What does that mean? In the second case, if k is equal to 1, k is equal to 1, use n minus 1, non-sunlight direct and sunlight direct, then we still use the values to cover it first. At this time, only n is used to subtract one piece. In this case, we have covered all the previous points. Finally, there is still this one point. This point is n1, this vertex is not covered by a straight line, but after a vertex, we just need to make it a direct sunshine. We might as well set this point, let's call it that line, we call it x plus b, and then bring in a value, for example, equals x minus n plus 1. Obviously, what about this parsing formula? This straight line, it obviously passes through n1, and it is also a straight line of sunlight, which means that k is equal to 1, which is also d. Let's look at k equals 2. What about when k is equal to 2? Then we will take the n minus 1 here. First of all, we used x equals 1 to 1, until x equals n minus 2 to cover, and finally there are 3 points left. These 3 points we want to use sunlight to cover directly, so let's give it a name. Call this point n1a and subtract this point n by 1. A competition for b subtracts 1 or 2 from this point n and calls it c. But we notice that kab here is equal to 0, kac equals minus 1. kbc is infinite. That is, we notice that as long as a straight line passes through 2 of these 3 points, then this straight line must be a non-sunny line. Then we can only use 2 sunlight lines to cover these 3 points now, and each sunlight line must only pass through one of the points. And those 2 sunlight lines pass through 2 of them at most, but we have 3 points and 2 less than 3, so we can't cover it all. In other words, we just do this. This way of reporting is not good. So what should we do at this time? At this time, we might as well remove a vertical straight line in front to fill the place behind us. First of all, we can think about it. Replace the line n-2x with n-2, and replace it with y equals a straight line like this. In this way, we still have these 3 points that are not covered, and these 3 points are completely isomorphic to the above 3 points, which means that converting n-2 obviously does not work. Then let's go to the previous one. Let's say we convert x equals t, and converts it to a y equals 1, then I convert an x to equal to t. I will have at least 3 points above me, at least 3 points, then each sunlight line passes through one of the points at most, then I have 3 points, at least 3 points, I have at most one of the sunshine lines, I only have 2 sunlight lines that are still 2 less than 3, and I can't cover them all. That is to say, k is equal to 2, and it is not true in every case. So p is equal to 2. It's not okay, and then we'll discuss it. If k is equal to 3, k is equal to 3, we will directly draw this graph for it. At this time, we push. It can be covered by 3 straight lines. First, let's go through these 2 points. Passing n-2. 1 harmony. What about the straight line of point n-1 or 2 points? Its parsing formula is called y equals. X is here. Subtract n plus 3. Apparently it is a straight line of sunshine. Let's look at this one again. Point n-2 or 3 and n-1. 1. What is his confidence? We can find out by simple calculations. Her sister is y equals minus 2x plus 2 people solve 1. Obviously, it is also a straight line of sunshine. Let's take a look at this one. It passed the dot. n-22 and n. 1. What is its problem-solving formula? Its solution is called y equals minus 1/2 x plus n in 2 parts plus 2. Obviously, our 3 straight lines, they are all straight lines of sunlight, that is to say, when k is equal to 3, we can give a similar structure, and the front is all covered by numerical straight lines. K is equal to 3 is true. Finally, let's discuss it again. What if k equals 4 or is greater than or equal to 4? Let's draw a picture now. Let's discuss k as 4 first. In the case of black and pink color, we have noticed 10 points like this. Each straight line of sunlight can only pass through a maximum of 2 of these points. For example, such a little sunshine is straight, and every sunlight is straight. More than 2. And what about us at this time? There are 4 sunlight lines, and the 4 sunlight lines can cover up to 4 times 2, that is, 8 points. But in this place we noticed that it had 10 points, so the trees that are directly covered by sunlight should be less than the total number of vertices. At this time, we add another one to make it k equal to 5. What about when k is 5? Each sunlight line can pass through up to 3 times. Why is this only 3 points for me? And then, we have 5 sunshine hours. 5 times 3 equals 15, which is exactly the number of vertices. But at this time, we notice that each straight line of sunlight must pass exactly 3, and then we find it at this time. A sunbeam passing through this vertex can only pass through up to 2 times. If we need to pass through this vertex 3 times and place the points accordingly, it is clear that the 2 resulting lines are not in direct sunlight. Finally, let's add another one. Let's discuss the case where k equals 6. If k is equal to 6, we find that each sunlight passes through 3 of them directly. But we have 6 sunny straight lines 6 by 3 that cover up to 18 parts. As for us, let's calculate that it has a total of 21 vertices, and the number of sunlight lines covered is still less than the number of vertices. At this time, we notice that when k is greater than or equal to 4, the number of vertices will rise with this k, and the number of vertices covered by this sunlight line will be greater than the number of vertices covered by this sunlight line. There is no way to complete the coverage, so let's sum up. K equals 0, 1, and 3 are the only true values. The key is to understand the definitions of very straight lines and sunny straight lines. Following that, varying constructs correspond to different k values. Ultimately, I arrived at the solution. Thank you.